Valley glaciers. Most of the lofty mountain ranges of the world are characterized by valley glaciers. They are the ice rivers that appear in valleys and basins in high altitude areas or greater mountain ranges. These are further subdivided into valley glaciers, cirque glaciers, niche glaciers and hanging glaciers. Valley glaciers. These are the glaciers which flow from cirques onto and along floor of the valleys. They are long and narrow ice rivers, originate in the ice caps or snowfields and arrive at the pre-existing valleys of mountains, flow down slopes. They are also known as mountain glaciers. Since they are first observed in the valleys of Alps mountains, termed as alpine glaciers. The length of the valley glaciers extend from a few hundred meters to above 100 kilometers and remarkably resembles systems of river streams. They get water as input in the snow form in the higher heads of mountains and comprise tributary systems that are most important to formation of main trunk system. The direction of flow is determined by the valley that the glaciers dwell in, and as the ice masses travel they erode and transform the landscape environment where they flow. In general, the valley glaciers are widespread in new and young fold mountain ranges like Himalayas, Alps and the coastal mountains in Alaska. For example, the Hubbard Glacier in Alaska is the largest valley glaciers with 130 kilometers long, and Siachen, Baifo and Baltoro, Batura and Hissa are such glaciers lie in Karakoram Mountains, India. Cirque glaciers. They form in a bowl-shaped depression, an armchair-shaped hollow on the side of mountains, termed as cirque, which have cut into bedrock. These glaciers are usually originate in regions with higher altitude mountains and are attributed by hemispherical or amphitheater shape. Niche glaciers. They are small upland ice bodies which exist upon a sloping rock face or in shallow hollow that the glacier themselves have faintly modified. Hanging glaciers. They are a type of valley or mountain glaciers which have situated on walls of the valley and are tributary glaciers remain suspended in a small valley above the main glacier. They become much thick that they spill over dividing ridges and join with the other glaciers in surrounding valleys. Piedmont glaciers. The glaciers which terminate on open slopes beyond confining mountain valleys and are fed by one or more large valley glaciers at the base of a mountain are called Piedmont glaciers. They are originated and extended horizontally without restraint over the adjoining valleys or lowlands. The best examples are Malaspina Glacier in Alaska, Butter Point in Antarctica and Frederick Shop in Greenland. The Piedmont glaciers are rare. At present, they have shrunk into the valleys of mountains, especially in the temperate zone. But in the Pleistocene Ice Age, there were several numbers of Piedmont glaciers. Thermal classification of glaciers. The ice in many glaciers is at the pressure melting point. The temperature at which ice may melt at a certain pressure, with the exception of a thin surface layer that gets chilled below freezing every winter. Under these conditions, meltwater and ice can exist together in equilibrium. At mean sea level atmospheric pressure, pure water freezes at 0 degrees Celsius. Higher pressure requires somewhat lower temperature to reach freezing. The freezing point of water decreases as the pressure rises. At the base of a glacier 1500 meters thick, the pressure is great enough to lower the melting point by 1 degree below 0 degrees Celsius. Since the pressure increases, some of the ice inside the glaciers melts as they grow thicker due to surface accumulation. Hallman presented another classification of glaciers based on the thermal characteristics or regime of internal temperature of glaciers. They are temperature glaciers and polar or cold glaciers. Temperature glaciers. These glaciers mostly found in low and middle latitudes. They are the glaciers which are at the pressure melting point throughout. The warm glaciers originate when there adequate heat to increase temperature of ice mass to the pressure melting point. Usually, these occur at the land surface when fin incidence melting of surface. If the surface meltwater meets ice below the pressure melting threshold, it sinks into the fin and freezes. Latent heat is released as the water freezes, increasing the glacier's temperature. This heating mechanism is so effective that it is typically sufficient to rise the ice or fin to the melting point during its conversion to ice on any glacier where fin experiences substantial summer melting. In this scenario, the entire glacier may be composed of ice at the pressure melting point. Water can exist throughout the warm glaciers all the way to the base because the melting point of glacier ice is in equilibrium with liquid water. In such a situation, there is a modest decrease of temperature with the depth in association with increased pressure. Cold glaciers. The glaciers which are hypothetically remains below the pressure melting point throughout a year are called cold glaciers. Cold glaciers are also known as polar glaciers. These glaciers have temperatures below melting point of ice from bottom to top. Such glaciers become warmer rather than colder with deepness, and the basal temperatures are lower than pressure melting point. Because of geothermal flux, the glacier's temperature increases with depth. Therefore, the cold glaciers are warmer at the bases than at the surface, and they can conduct the geothermal heat flux to the surface where they get dispersed into the atmosphere. Allman has subdivided the polar glaciers into two types, namely high polar glaciers and subpolar glaciers. In the high polar glaciers, in the fins, the temperature remains well below the pressure melting point throughout, and even in summer, there would be no melting on the surface in the ice accumulated regions. In subpolar glaciers, an intermediate type, a thin surface zone reaches the melting point in summer, but temperatures beneath the upper several meters of ice remain below freezing. The materials in the subpolar glaciers comprise of crystalline fins, down to a depth of 10 to 20 meters, but in summer the surface ice mass undergo melting and produce water. The coal-based glaciers move largely by internal shearing and deformation and will be unable to abrade the beds. The temperature glaciers have a high component of basal sliding in their movement with much greater possibility for erosion and basal deposition. The larger glaciers require not be totally warm or cold in all their parts. Both the Antarctic and Greenland ice sheets are cold at the base and warm at the surface where they are thickest, while they are frigid from bottom to top in their thinner outer regions. Summary: glaciers comprise of ice that has been modified from snow by flow, recrystallization and compaction processes. They remain part of the cryosphere, the region on the land where the water permanently in the frozen condition. Glaciers can be classified into major groups on the basis of their geometry, morphology, regime of temperature in them. Orman classified the glaciers on morphology and thermal characteristics as basis. The major types of glaciers include continental glaciers, valley glaciers and Piedmont glaciers. The ice in temperature glaciers is at the pressure melting point and water produced at the glacier bed. In polar glaciers, the ice is below the pressure melting point, whereas the subpolar glaciers, a thin surface zone reaches the melting point in summer, but the ice underneath is below freezing point. Therefore, glaciers rely on for their survival on low temperature and sufficient precipitation processes.